All right, let's talk about that little bit of digital magic that happens all the time. You know, that secret handshake between your browser and a website that lets you stay logged in without having to type your password a million times. We're going to pull back the curtain on exactly how that works. Seriously, have you ever thought about it? How does Netflix just know it's you when you come back to finish a show? Or how does your Amazon cart remember what you put in there yesterday? It's not magic. Not really. It's actually a super clever piece of tech, and it all comes down to that digital secret handshake. And the key to that handshake is something called a JSON Web Token, or JWT for short. Now, the absolute easiest way to think about a JWT is to imagine it's a digital passport. It's this compact, super secure string of text that your browser shows a website to prove who you are. Simple as that. So, if it's a passport, what's actually written inside? Well, a JWT isn't just one block of text. It's actually made of 3 separate parts, all neatly joined together by a dot. Let's break down what each part does. First up, you've got the header. Think of this like the cover of the passport. It's just some basic info, some metadata that tells the server 2 simple things. Hey, this is a JWT, and here's the algorithm I used to sign it. That's it. Next, we get to the payload. Now, this is the interesting part. This is your personal information page. It's where the important data is stored in what we call claims. Things like, your user ID, what you're allowed to do, and this is crucial, when this digital passport is going to expire. And finally, my favorite part, the signature. This is the official tamper-proof seal. The server creates this by mixing the header, the payload, and a top-secret key all together. If anyone, and I mean anyone, tries to change even one tiny character in the payload, the signature won't match anymore. The server will know instantly that it's a fake. So you see how these 3 parts work together, right? The header sets the rules, the payload carries your info, and the signature makes sure the whole thing is legit. It's this structure that makes JWTs so incredibly useful and secure. Okay, so now that we know what's in the passport, let's actually follow it on its journey. How does this thing get from the server to your browser and back again? This right here, this is the handshake. It's kind of like a 6-step dance. First, you log in with your username and password. The server checks them, and if they're good, it creates your unique JWT, your passport, and sends it back to your browser. Your browser then tucks it away safely. And from that moment on, every single time you do something, like click on your profile, your browser just shows the server that passport. The server takes one look at the signature, says, yep, looks good, and lets you in. No password required. Okay, so your browser is now holding on to this very important digital passport. And that brings up a really critical question. Where do you keep it? I mean, you wouldn't just leave your real passport lying on a coffee table, right? The same idea applies here. Choosing the right storage spot is honestly one of the most important security decisions in this entire process. If you get it wrong, an attacker can just walk by and snatch your passport, and then they can pretend to be you. Big problem. So you basically have 2 main options, something called local storage and a special kind of cookie. But here's the critical difference. Local storage is like an unlocked drawer. Any script running on the page can peek inside. This makes it wide open to something called a cross-site scripting attack. But a secure HTTP-only cookie, that's like a locked vault that JavaScript physically can't open. I mean, this table says it all. HTTP-only cookies are the industry standard for a reason. Because they can't be touched by client-side JavaScript, they are basically immune to those XSS attacks where a hacker tries to steal your token. That best recommendation? Yeah, that's not just a friendly suggestion. It's a security must-do. And hey, don't just take my word for it. The source material puts it perfectly. When you set up cookies with all the right flags, HTTP only, secure, and same site, you're building multiple layers of defense. It's just the smarter, safer way to protect your digital identity. But wait, we can actually take security one step further. Instead of just relying on a single passport, most modern systems use a clever 2-key approach. This gives us the best of both worlds, tight security and a great user experience. Think of it like a trip to a theme park. The access token, that's your day pass. It's what you show to get on all the rides, but it doesn't last very long. Then you have the refresh token. That's your annual pass. You keep that one tucked away somewhere extra safe, and its only job is to go to the ticket counter and get you a new day pass when the old one expires. So that access token, your day pass, it expires really fast. We're talking like 15 minutes. And that's a huge security feature, because if a thief somehow manages to steal it, they only have a tiny window of time before it becomes totally useless. Meanwhile, your long-lived refresh token is working quietly in the background, keeping you logged in without you even noticing. It's pretty genius. So let's put this all together. If you're building a secure, modern login system, what are the absolute golden rules? Let's just quickly run through the biggest takeaways. First, and this is non-negotiable, always use HTTPS to encrypt everything. Second, store your tokens in HTTP-only secure cookies. Just don't use local storage. Third, use that two-token system, a short-lived access token and a long-lived refresh token. And of course, when a user logs out, you have to make sure you actually clear those tokens properly. And there you have it. That secret handshake happening behind the scenes isn't really magic at all. It's just a really well-designed system of digital passports, secure vaults, and a couple of clever keys. It's what keeps you safe while making your life online just easier. So now that you're in on the secret, what piece of digital magic should we demystify next?